Hello Warriors, this is Miss Lemons, and today we're going to be going over your mole concept packet. We're going to be focusing on going from atoms to moles. I've already created 3 additional videos that go over grams to moles, moles to grams, and moles to atoms. So make sure you have this worksheet and a pencil as well as a calculator and your periodic table. And we're going to go ahead and start with practice number 19. Again, if you have not done the other ones, then you need to make sure you watch those videos or give those practice problems a shot first. So, number 19 says to determine the number of moles of lead in 3.50 times 10 to the 25th lead atoms. So we're going to start with what we know. That's 3.5 times 10 to the 25th lead atoms. And it's asking us to locate the number of moles of lead. So we have to figure out what conversion factor we're going to use. So let's go ahead and give that a go. Again, we are looking for atoms and moles. So we want to pick a conversion factor that contains both atoms and moles. So the molar mass contains moles and grams, and Avogadro's number includes moles and particles. Remember, particles can be atoms, ions, molecules, formula units, whatever. So the one that we want to use is going to be Avogadro's number. So our conversion factor is going to be 1 mole of X, but in this case it's going to be lead, Pb, is equal to 6.02 times 10 to the 23rd power atoms of Pb. So now we're going to go ahead and set up and solve. Remember, we always start the same way. So we are starting with what we know over 1, so that's 3.50 times 10 to the 25th atoms of lead. What's on top must come down. So if we have atoms of lead on top, we need to have atoms of lead on the bottom. So how many atoms of lead? Well, look at your conversion factor. 6.02 times 10 to the 23rd power atoms of lead. So if you use 1/2 of your conversion factor on top, that's 6.02 times 10 to the 23rd atoms of lead, you have to use the other half of your conversion factor on top, 1 mole of lead. Now I know I've done this correctly because atoms of lead on top cancels with atoms of lead on the bottom. So we're going to go ahead and multiply our top and bottom. So that's going to be 3.50 times 10 to the 25th atoms. And 1 times 6.02 times 10 to the 23rd is 6.02 times 10 to the 23rd. Now you have to be really careful when you type this into your calculator. So give me a moment. I'm going to erase kind of the work here. So make sure you take a look at what we have and make sure your setup matches what I have, because I'm going to be erasing everything in just a moment. So pause the video now so you can get down this setup. Okay, so you can see that I went ahead and I rewrote this so I could fit all of the work right here on the slide. The final answer, the raw, unrounded answer I got was 58.13953. Now, if you end up with something raised to the power of 10, that means you probably typed it into your calculator incorrectly, so make sure you're putting parentheses around every single piece of scientific notation. So when you type it into your calculator, you should type it in like this. Of course, we're not completely done yet. We have to round according to the rules of sig figs. We started with 3 sig figs. This is a trailing 0. Trailing zeros with a decimal are significant. So if we want to end with 3 sig figs, we're going to underline our top 3 sig figs and then round up or down. And because this is less than 5, we are rounding down. So our final answer is 58.1 moles of Pb, or lead.